Hey AP Chem. Today what we're going to do is we are going to look at a redox titration that we actually did back in the fall. So this is a titration where we're trying to figure out the amount of hydrogen peroxide present in a 3% solution from the grocery store. So what I have presented you with here is I've actually presented you with my lab notebook pages. When you do labs in college, you'll be asked to write the purpose, the full procedure, the full data tables, and calculations and all that before you come into lab. So this is very much what a lab notebook set of pages would look like in a college level chemistry class. What I'm going to ask you to do today is tackle the calculations for this lab, again, based on the data that I've collected. So we first looked at a redox titration by thinking about not an acid-base reaction where you're coming to the equivalence point where you've consumed all your acid by adding enough base. But for a redox titration, what you're doing is you have an oxidized species, a reduced species, and you've hit that equivalence point when the number of moles of one added is equivalent, at least stoichiometrically, to the one that you had in your flask. So what we're going to be looking at here is two half reactions. We've got hydrogen peroxide decomposing into oxygen gas and hydrogen ions. This will take place in an acidic environment. And then we also have permanganate ions going to manganese ions. So this is the reduction half reaction. This is also the indicator in our reaction. You'll recall that permanganate is a deep purple because the manganese ion in its 7+ form is deep purple. And then the manganese ion as a 2+ ion is colorless. So you drop the permanganate from the burette into the hydrogen peroxide solution and it goes colorless. So it's purple in the burette and then goes colorless. Well, what that tells